Today we will see how we can write the dual to the given linear programming problem. So here the question is, write the dual to the given linear programming problem. Maximize z is equal to x1 minus x2 plus 3x3 subject to the constraints x1 plus x2 plus x3 less than or equal to 10, 2x1 minus 0x2 minus x3 less than or equal to 2, 2x1 minus 2x2 minus 3x3 less than or equal to 6, and x1, x2, x3 is greater than or equal to 0. So this is in the primal form and we need to convert this to the dual form. In the primal form, it is like maximize z is equal to Cj xj, that is sigma Cj xj, and subject to the constraints which we write it as sigma Aij xj less than or equal to Bi, and we will convert this to dual, and here xj is greater than or equal to 0, and in dual form the same thing we'll write it as maximize will turn to minimize. So it will be minimize zy, here x will be y, is equal to sigma bi yi, then subject to sigma aji yi, and it will be greater than or equal to Cj. And here our yi will be greater than or equal to 0. So it is changing as maximize to minimize. Then Cj, instead of Cj, here we'll write it as Bi, and x will be changed to y. And as you can see here, Aij and Aji, that is Aij is equal to Aji. What this means? This means that A11 is equal to A11, and if we say A12, then it will be equal to A21. All these things I'll explain you while we are solving this sum. And here Bi, instead of Bi, we write it as Cj. So now we'll just solve this. Firstly, it is maximize, which will be written as minimize, and then z, which is zy, is equal to, it is sigma bi yi, that is, we'll write it as b1 y1 plus b2 y2 plus b3 y3, as we are having 3 variables. This is our b1, this is our b2, and this is our b3, because Cj is replaced by Bi, and we'll write x1 as y1, x2 as y2, and x3 as y3. So this will become minimize zy is equal to 10y1 plus 2y2 plus 6y3. Then subject to the constraints, and that we'll write it as sigma aji greater than or equal to Cj. What is our Cj? Then it is the coefficient of the variables of the objective function. that is z is equal to x1 minus x2 plus 3x3. From that we will write, firstly I'll just write these three equations. From that I'm writing it as y1, y2, y3, y1, y2, y3 and greater than or equal to. Now we'll see the coefficients and the signs. So firstly let's just write c1. So our c1 will be the coefficient of x1, which is 1, then the coefficient of x2, which is minus 1, and c3, which is the coefficient of x3, that is 3. So this is how we'll write it, greater than or equal to 1, then the second one greater than or equal to minus 1, and the third one greater than or equal to 3. Now for writing AJI, we'll see the coefficients of x1, and that we'll write in our first equation. So the first coefficient of x1 is 1. Then for the second equation, coefficient of x1 is 2. So it will be plus 2 y2. And for the third, it is again 2. So it will be plus 2 y3. Then for the second equation, we will see the coefficients of x2. So it is, as this is 1x2, so this will be y1 minus 0y2 minus 2y3. And same way for the third equation, see the coefficients of x3. So it will be plus 1, then the second one is minus 1, and the third one is minus 3. So these are our constants. And that is, from this what we can write as that our AJI are the coefficients of x1. This is for the first equation. Same way for the second constant, AJI will be the coefficients of x2. So this is how you can understand that A12 is equal to A21. And for the third constant, it will be the coefficients of x3. And then our last step, we'll write y1, y2 and y3 greater than or equal to 0. So this is how you can find the dual to the given linear programming problem. Thank you.